This is a snail embryo. Scientists are using virtual reality to explore inside this dynamic, microscopic world. But exploration of this tiny universe didn't start with 21st century technology. It began more than 100 years ago with pencil, paper, and a lot of patience. In the 1890s, a group of scientists in Woods Hole, Massachusetts, wanted to figure out what happens when an embryo forms. To do so, they tracked developing cells by painstakingly recording each cell division, one drawing at a time. One of these scientists was Edwin Grant Conklin.
Cellular phenomena. I was especially interested in that.
Conklin studied the embryos of a snail called Crepidula fornicata, which he chose for its relatively large, transparent eggs.
I followed individual cells through the development. Followed them until many people laughed about it, called it cellular bookkeeping.
At the time, scientists held two different views on embryonic cells. Some thought that cells were pre-programmed to form organs. Others believed cells were just randomly assigned to form organs way down the line.
The work went ahead and grew, but it showed that these individual cells had definite fates. They went into certain parts and not anywhere and everywhere.
Conklin published his paper in 1897 with 105 hand-drawn images.
One of the main things that initially drew me to Conklin's work was just how beautiful the illustrations are in his paper.
For her senior thesis at Brown University, Beatrice Steinert wanted to figure out how Conklin traced the fate of each cell.
I was interested in his study because of the kinds of questions that he was interested in answering and his ability to harness the tools that were available to him at that time to answer those questions, which is really just a remarkable feat.
So she decided to grab a pencil and draw the embryos herself. She used a device called a camera lucida, similar to what Conklin used in the 1890s.
A camera lucida is essentially a series of mirrors that attaches onto the microscope, and it works such that when you have a piece of paper in your hand and a pencil lying right next to the microscope, the image of that is actually reflected into the eyepiece. So when you look through the microscope, you can actually see your hand and the piece of paper and your pencil right on top of the specimen that you're interested in. And this allows you to directly trace that specimen.
But one challenge is that embryos are three-dimensional. And with this device, a person can only focus on one slice of the embryo at a time.
And so what Conklin had to do with the camera lucida is he would get one plane of focus, and then he would sketch that plane. He would shift the focus, sketch another plane directly on top of the sketch that he had just made. He would shift the focus again, sketch another plane.
It was difficult and time-consuming work. Each of Conklin's drawings were multi-layered sketches, and they had to be combined to make one full image.
I still don't fully understand how he was able to do it, especially because in the later stages of the embryos, there gets to be so many cells that it just seems impossible without some of the more modern tools that we have now to track cell lineages.
More than a century later, computers like the ones at the yurt at Brown University can illustrate embryos in ways Conklin probably imagined.
Maybe what we see, that's what was in his head. At least what I think must have been going on in his head is that in looking at these embryos in all these different ways and through all these different methods, he was kind of constructing a mental image of what was going on. And then part of the challenge was just, how do I translate this mental image onto paper? And maybe if he walked into the yurt, there would be his mind.